Today we are making a music machine inside Max. We are going to take sort of some really basic music theory and turn it into a machine that automatically makes music for us. This is a more complex example in front of us, but an example of what you can achieve. So if we start the machine, it breaks a harmony from the C major scale and the first 6 chords, and then automatically puts a melody on top of that based on the current chord that's being played. In this example, we're using something called a Markov Chain that has analysed how Mozart wrote his songs and has given us a mathematical representation of the chances of what chord are to be played next. To start, we're going to make a simpler version that just looks at really basic music theory and something called the diatonic scale to work out what chord should be played and then how to play it. So let's go ahead and start a new patcher. To start off with, we are going to be referencing this lady a lot, Karen Ramirez. She has a massive amount of videos on YouTube that cover the basics of music theory. And we're going to use her video determining the chord progression in a song to help us make a logic machine. So I'm just going to keep a reference of that. Made using info from, so thanks Karen if you ever see this. Now all of our music is going to be made using the C major scale, and this is the simplest one, and for those that don't know anything about music like me, the C major scale is an entire set of chords that don't have any sharps or flats inside of it. It's purely just bass notes on the piano. Now I'll let you go and find it out yourself, but the C major scale is made up of 7 chords. The first, which is a major, is the C, E and G notes. The second, which is the minor, is D, F and A notes. Third, which is also a minor, is the E, G and B notes. Fourth, which is the second major, is an F, A, C. Fifth is also major at G, B, D. And then we've got 6th minor at A, E, C. And we won't use it, but the 7th chord in this, the 7th diminished, is B, D and F. But I'm going to remove that because we're not actually going to reference that 6th chord. Because if we skip along this to where we talk about diatonic harmonies, I'll let you watch the video, but basically when you write a song, there is a natural chord progression that you can follow to help you make things work. And these are, anytime you play a first, you can play any chord. Anytime you play a second, you can play the 5th. Anytime you play the 3rd, you can play the 6th, 4th, 1st, 5th, and so on, so on. I'll explain this in a bit more detail when we actually get to it. But for now, we need to make a machine that lets us play these notes. Now the simplest way to do this is to use the built-in MIDI player on your PC. I'm using Windows, so I'll use the Windows default. On Mac, I'm sure there's a basic one that will allow you to play keys. So I'm going to use the K slider built into Max, which is the on-screen keyboard. And anytime you push a key on this, it gives you a number that corresponds to the MIDI note of that. So for example, middle C here is a 60. If you put that into a make note, and then a note out, we can make notes play based on numbers. And we're going to use this logic to build our entire machine. So the first thing we're going to do is make all of these chords using max MIDI numbers. Now, the first chord in C major is C, or the first note I should say is C. Instead of the middle C, I'm going to use the first lower C, which just starts at 48. And I'm going to take a note of that in a message. The next one is E, so I'm going to go up. Next one is, that means the 52. And then finally G is 55. And if you're like me and don't really know anything about music, The way that a keyboard runs is in octaves. Starting at the middle note, which is C, it runs alphabetically. So I know that this is C, this is going to be D, E, F, G, and then it resets to A, B, C, etc. So from 72 to 60 is a full octave of C to C. And I'm using that logic to work out that this is C, D, E, F, G, A, B, C within that respective octave. Don't worry about where you pick to start your note counting from, because we'll put in something that will allow us to shift octaves automatically later. So I'm going to continue going through this process and make all of these cards based on their MIDI number inside Max. So I'm just going to open up and bring over my chord panel. So I'm going to take this. It's a good practice for you to do it and go through and learn what each of the numbers are, because it will become second nature eventually that you'll know which note is which number in the MIDI scale. Okay, so from there, I now know that I have each of the notes in the C major scale starting at the second C from middle. What happens if I want to play the middle C octave? So the first thing I'm going to add is something that allows us to automatically change that. So I'm going to add an integer that says select octave. And then if we have a look, middle C is 60, but the C we started with is 48. And the next C down is 36. 36 to 48 is 12. 48 to 60 is 12, 60 to 72 is 12, and so on. So we know that notes, including all the sharps and flats that aren't included in our current calculations, is 12 notes. So we can simply times the number we're doing by 12, and then add that to the note that we want to play. So I'm going to add 0, and then because we are using messages, we need to bang them add as well. I'm going to add this to here. So now if I push this instead of 48, we'll get 60, instead of 52 we get 64, instead of 55 we get 67. And to test that, so 48 to 60, 52, which is E, to 64, and then finally G, which is 67 to 67. So already we have something that allows us to play notes and then also shift them through octaves. So if I disconnect that from here and plug that in down here, I can quickly play all of the notes and chords in the C major scale at any octave on the keyboard that I want. I'm going to remove them quickly. Next thing we want to do, so we have all the notes and the octave that we want to put it in. I'm going to just note that this is bass -1 from center C. We want to connect all of these notes up. Now, what we want to do is make it so that when a number is played, and luckily 1st through 6th, i.e. 1 through 6 is played, that it plays the entire chord, or gives us the option to. So I'm going to do something, I'm going to do a counter to let us test it here. I'm going to do counter 1 6. So it's going to count upwards and then repeat it 6. And then I'm going to do a metro. So every second it's going to give us a beat. Turn that on, look at the output. So every second it's going to increment to 6, when it'll then restart. We need a way to play each of those notes as they come in. So I'm going to route this through 1, 2, 3, 4, 5, 6 different options. I'm going to connect it up. So 1, 2, 3. That is the first chord. 2, 3, 4. That's the second chord. So if this doesn't make sense, that's what I'm doing is we're taking a number in that's being made by a counter in this case, but we can ignore that. So we can visualize that as this. So we have a number that is 1 through 6 coming in that is then being routed out into one of the 6 chords that we've just made. This should be 53. I accidentally just changed the number of that. So what's happening now? Every single time this counter changes, another of these 3 notes is getting in max banged. So if we visualize, when it comes around to being chord 3, non 3, this will output. And we can use that to make select notes. So if I just move this over here, as that's our octave selector, what we want to do is bring all of these into our addition, just to make sure that we can change the octave correctly. So now it will go through the 6 chords in progression and then play all 3 of the notes at the same time, offset by the octave that we've selected. I'm just disconnected that bang there because I'm not sure we actually want that now that I'm looking at this. So one thing you'll notice, the integer coming out only displays one number, but if we print the output, you can see that all 3 of the numbers are being run through that addition of 12. And this is important because we're going to use this to separate, we're actually going to re-separate the numbers out now that they've been added back together. So what we're going to do is we're going to run them through ZL sort, and we're going to give it a value of 0. And that just means it's going to ascendingly sort these numbers for us. So now we should see the highest of the 3 numbers being displayed in each of these. If I reset this back down to 0, sorry, this is displaying the lowest of the 3 of the chords that we're putting into it. So for example, when it resets, it's C, D, E, F, G, and then A, C, etc. We then want to get the 3 numbers back out. So I'm going to put it into something called a cycle, and I'm going to pass the cycle a message called thresh 3. So we need to cycle by 3 outputs. When I pass the cycle the message of thresh 3, that's telling it that every time it receives a number that's not 0 to start again, and that means that all our numbers will always be in the correct order for us. So now if I do 1, 2, 3, every time that our counter increases, we will receive our 3 notes of the chord in descending order based on the octave that they're going through. So here, if we set this to 0, there's no change, but if we set this up to 1, it means that it will automatically increment the values by 12 and then give us the adjusted notes of that chord. So we have a system that can make the C major chord in any octave on the keyboard in max. And that's quite a cool thing to have already. The next thing we need to do is make it so that we can play the right chord at the right time. So ideally, as we did have up here, we would just plug all three notes into a make note, and then it's playing the chord. Lengthen them out a bit so it lasts the full second. But that's very boring and it's not very harmonic. We're going to use something called diatonic harmony that Karen thankfully teaches us to make what is a natural chord progression for music written in the C major scale. And all it is it relates to when you play one of the chords, what is the most likely next chord to come along, or what sounds good, basically. So here we've got our first chord, second, third, fourth, fifth, sixth. And the general rule of thumb is that if you play the first chord in a scale, so in this case C, E, G, you can really play any chord after it and it'll sound alright. Second chord, mostly only the fifth chord's going to sound fine. Third chord, you're going to want to play sixth. Fourth, you can play either one, or five. Fifth chord, you're going to go back to one, and then sixth chord, you're going to play the second. And that is using exactly notes taken from Karen. And sticking to this as a rule of thumb means that you'll have something that sounds and works together musically. So we want to build that as a state machine. So we are going to have an inlet, pass current chord in, and then we're going to have an outlet, pass new chord out. So what we want to happen in here is a bunch of logic that is using this as a guide. So we're going to simulate what comes in with a number, so it can be 1 through 6, and we're going to pass out a number 1 through 6. So if the number in is equal to 1, then we want to send a bang, and that bang is going to randomly pick a number between 1 and 5. It's randomly going to pick a number between 0 and 5, excuse me. We want to add 1, so it's between 1 and 6. And then we output that number. Let's visualize it. So if I bang this, oh, that's why, it's because I've said if it equals to 1. Yeah, sorry. So now if we do that, we'll randomly create a number between 1 and 6 every single time. Just looking at this, I think what we actually want the ranges to be is 6, and that will give us a range of 6 between 0 and 5. We add 1, gives us the option of between 1 and 6. Yeah, excuse me. So the amount of numbers you want in here, starting at 0 plus 1 to give us it between 1 and 6 rather than 0 and 5. So we add that there, and add that there. So now we have 1 taken care of. We need to do it for 2. So if the number is, the chord is equal to 2, then it's going to be set equal to 5. If the chord is equal to 3, then it's going to be set equal to 6. Now, another special one, if the chord is equal to 4, then we want to bang, because we're going to use this random method again, but instead of 6, we're going to do 2. So when it receives a bang, it's going to randomly generate a number between 1 and 2. And then we're going to scale that number between 1 and 2, between 1 and 5. So it's either going to be 1 or it's going to be 5. A quick test. 5, 1, 5, 5, 5, 5, 1, 5, 1, etc. If it is 5, then we make it equal to 1. And finally, if it is 6, we make it equal to 2. Connect all these up. Connect all these up. So now we have the basic logic of the C major harmony scale that means that if we play chords and then want to calculate the next chord that should be played by our music machine, we have something that works. I'm going to connect those up to the inlet and outlet. Quick test of this, so if we play 2, it should be 5, 2 to 5. If we play 3, it should output 6. If we output 4, it's going to do 1 or 5, and it's given us 5. If we do 6, 5 is going to give us 1, and 6 is going to give us 2. Sorry, I'm scrolling too fast. But there you get the idea. So now we have something that can take the chord that's currently being played and work out the one that should be played next properly. So this logic is going to sit above where our current counter is. So we can remove this. We need something that records the current chord. And then every time that the metro started, let's start at chord 1, because then it can go to any. Don't want that to connect there, I want to connect that there. Pass that in and pass that in. Give me an integer. So now if I start it, you can see every time that we bang in, it gives us a different note. All we need to do is pass this chord back in here. So now we connect the metro up, so we have a system that plays the current chord, runs it through our logic, and tells us which chord should be played next, all within the same 100 milliseconds, or what we are calling a bar. Next thing we're going to do is I'm going to move this down. This number here isn't what's used. We use this number here. So we connect that to our root, connect up our make note, and now we have a system that will randomly go through the chords in the C major scale using the harmony to make sure that it plays a chord that sounds right, and that will continue forever. So you can guarantee nearly that the chords coming out are going to make it music that sounds okay-ish for a computer making it. Something that we could do to make it a bit more exciting though, so earlier we made it so that we could get the individual notes back out that were going into the Octave Multiplier, and I don't see a reason that we shouldn't be using them. So what we need to do is we have the current bar length. I'm going to turn this into an integer. With a load message of 1000. So we start with the default of a second long note bar. I'm also going to make 2 sends called tempo and start, and connect them to the main toggle and the tempo number respectively. And then I'm going to receive start, and I'm going to receive tempo, and I'm going to put them into a secondary metro, and this metro is going to have a default beat of 0. So every 0 milliseconds it sends out a beat. But what we actually want to do is change that number anytime the tempo is changed, so it's a fourth. Now anyone that's slightly musically inclined may understand what we're doing here, but what we're saying is every quarter of the tempo send a beat. So if we start, every time that our main metro ticks, our secondary metro will tick 4 times. And that means that we have the ability to play quarters within, or fourths within our make note, within our bar. To give us the option to play as we currently are with the full chord, I'm going to add a switch. output from 2 inlets, input to one of 2 outlets. I'm going to add something called a 250 and a 750 message and pass that into the duration part of our make note. And that means that when we want the full chords to play, we're going to ask it to make the length 3/4 of a second. And when we want one chord note to play in the chord, we're going to skip that to 1/4 of a second. I'm going to make 2 roots. 2, 3, 4. On the first one, I'm going to ignore when it matches to 1. And when it's 2, 3, and 4, I'm going to ask it to play the notes. I've put my metro straight in. Sorry, we want to have a counter of 1, 4. So we need something coming out of the metro that counts those beats. And let's visualize what is being played with a K slider. So there we can see that it's going through the chords. If we make another root based off the same counter, but instead put each of them into all 3, I'm going to put, when the count is 2, to play all 3 notes, and then send the metro to one of the 2. Counter in, and then that's routing to the right one. Add a big toggle. So now, if we start it, second thing I want to add is I'm just going to quickly, every time that this counter receives the start command, we're going to reset it to 1. And that just means that we won't end up with it randomly skipping between the 3 notes. We want to make sure it goes through each of them in the correct order. And I'm going to mix these up slightly so that these 2 and these 2 I'm going to swap around. So now it plays in ascending order, just to give us a slightly nicer note. And there we have the beginning of our automatic music machine. It automatically takes a chord from the C major scale, works out which is best to play next, and then plays it. And then using our G switch, we can control whether it's playing the full chord or the sequence of notes in that chord. In the original example, if we load it back up, In a slightly more complex way, this uses something called a Markov chain, which, as described earlier, is the chance that what are the odds of a note being played next by a composer. So this was done using statistical analysis of hundreds of their songs. So for Mozart's Major, this is what the chances of him playing each note are. So if he played a first, he was more than likely going to play the fifth chord after that. And if he played the fifth, he was more than likely going to play the first chord. So we made a slightly more complex state machine for a bunch of famous composers, and then added a harmony on top of it, or added a melody on top of the harmony that takes single notes from the chord that was selected and then plays them on the 8th instead of on the 6th, so on every middle note. So here we have a root for 3, 6, 8, and we have a counter going into it from harmony. So we have an 8th counter here that works out when to play every chord, or every note of the chord. Each are randomly selected as they go, and each are given a random range of 3 octaves to go through. And with very little work, you can create a machine that makes music automatically to a fairly chirpy and happy standard.